Hello juniors, today we're going to see electronic assignment number 23, which is the discriminant of quadratics. We're going to see the concept of a discriminant, and you'll see that this has a very interesting application in order to study the quadratic functions. So let's begin with this. The objective for today's class is to find a discriminant and distinguish the nature of the roots. That is, if there are two distinct real roots, two equal real roots, or no real roots. Okay, so to begin with, we're going to start by quickly reviewing what we were doing last class, and I'm going to show you something interesting about when to use each of the different techniques to solve quadratic functions. So remember, we've studied 4 different ways in which we can solve quadratic equations. The first one, solving by factorization. The second, solving by computing the square. The third one, applying the quadratic formula. And finally, the fourth is using the GDC. Okay, so when you're facing a problem, when do you use each of these techniques, or which one would you pick, right? So here's like a small guide that will let you choose this according to the shortest time that it would take each of these techniques to perform, right? So it says, first question, when you're given a quadratic equation, this is a quadratic equation, right? Are you using technology? If the answer is yes, then go to the fourth method, which is using GDC, and graph the functions and find the x-intercepts. That'll be the easiest way. If you're not using technology, does b equal 0? B is this value over here, right? If b is 0, then solve by taking square roots. For example, if we have x squared plus 25 or x squared minus 25 equals 0, you see that there's no b here, so we can just take the 25 to the other side and take square root of both sides, and we will get plus or minus 5, okay? So that's not one of the 4 techniques, but it's an easy way to solve this. So if b is 0, then solve by taking square roots. If it is not b 0, the question is, does ax squared plus bx plus c is easily factored? If we can solve by factoring, then we apply technique number 1, which is solving by factorization. And no, then you need to see this question. Is a equal to 1 and is b even? If yes, you solve by computing the square. If not, you solve with the quadratic formula. Remember, the quadratic formula may be applicable every time, right? The only problem it has is that it's quite long and it's easy to get confused in the way. So I would personally solve by factorization every time I can. And if I can't solve by factorization because it gets too complicated or whatever, then I would do the quadratic formula. But I generally won't use the second technique, which is solving by completing the square. Okay, so let's go to today's topic. First of all, we're gonna once again review what a root is. It says roots, x-intercepts of a quadratic function. So these 2 points over here are the roots of this quadratic equation. And some synonyms of roots are solutions, zeros, x-intercepts, okay? So that's for you to remember. Okay, next we're gonna do this short investigation in order to try to understand what we're gonna study today. And it says, a quadratic equation may have 2 distinct real roots. Roots, remember, are x-intercepts. 2 equal real roots or no real roots. Complete the investigation to explore the nature of the roots of a quadratic equation. So number 1, for each equation, write down the value of b squared minus 4ac. Use the quadratic formula to find the real roots and then describe the nature of the roots. Use your GDC to make a rough sketch of the graph of the related function. Record your answers in a table like the one below. The first row has already been completed for you. Okay, so we're gonna do this together. The first, we have this equation over here, which is negative 5x squared plus 6x plus 2 equals 0. As you can remember from previous classes, we can identify the value of a, b, and c. Once we have identified that, the table asks to find this term over here, which is b squared minus 4ac. You will understand why we're finding this in a while. But for now, just follow the instructions. So this is b squared is 36, and then minus 4ac, and all of this should give us 76. If you want, you may try doing this on your own with your calculator. Then we can determine the roots or x-intercepts of the quadratic equation. In this case, this could have been determined using GDC as well. So these are you see that here are two different roots. Why? Because one is for the positive sign and the other one is for the negative sign. So what can we say about the nature of the roots? There are two distinct real roots, right? We have two different roots. And if we sketch the graph of this, you see that we're going to get a sketch which is like this. And if we observe at the roots or x-intercepts of the graph, we see that effectively we have two distinct real roots. That is, the parabola crosses the x-axis at two different points, okay? That's why we say two distinct real roots. So let's see example B. 3x squared plus 2x minus 1 equals 0. If we find b squared minus 4ac, remember b is 2, a is 3, and c is negative 1, okay? So if we do that quickly with our calculators, you may do this with your own calculator if you want. This would be 2 squared minus 4 times a, which is 3, times b times c, which is negative 1. This gives us 16. Okay? The roots, let me find the roots quickly using polynomial degree 2 in the calculator. This would be 3, 2, negative 1. I get two roots. The first one is 1/3, and the other is negative 1. So once again, I have two distinct real roots, right? So I'm going to write that here. Two distinct real roots. If I sketch this graph, let me sketch that for a second. I have it here now that I remember. Here, this is a graph, okay? So you see that we have two distinct real roots. One over here, which is negative 1, and the other one over here, which is 1/3, okay? So I'm gonna make this same sketch over here, and we get a parabola that looks like this. Kind of. A little bit more like this. Okay? So there are two distinct real roots. The parabola crosses the x-axis twice. Then let's go to part C. In this case, b is negative 4, a is 1, and c is negative 2. So once again, negative 4 squared minus 4 times 1 times negative 2. This gives us positive 24. Once again, we get a positive number here. Then, if we find the roots, let me do the graph for part C here. This is the graph. So the roots would be those two numbers, negative 0.449 and 4.449. So negative 0.449 and 4.449. Once again, we get two distinct real roots. So I'm going to copy this. And the graph looks like it's a happy face. So the graph looks something like this. Okay. Then for part D, negative x squared. Okay, if we find the discriminant for this case, we would get a b squared, that's negative 6 squared, minus 4 times a, which is negative 1, times negative 9, which is c. This gives us 0. Okay, so let's graph this to see what's happening. Graph number D, letter D is this one. What do you notice here? That the parabola is tangent to the x-axis. It touches the x-axis at only one point, which is that point over there, -3 and 0. So let me write the root. There's only one root, which is -3, right? So in this case, we're gonna write that this has only two, or the same as saying two equal real roots. So I'm gonna write here two equal real roots. I should say roots. Okay, so in this case we see that a parabola that is tangent to the x-axis at this point, okay? It touches the x-axis at only one point. So you see that occurs when this value that we calculated here is 0, okay? We're gonna see the rule in a second. Let's go to exercise E. If we calculate b squared minus 4ac, this would be 12 squared minus 4 times -2 times 4 times 9. This gives us 0 once again. If we graph this parabola, we would get something like this. You see that once again, the parabola touches the x-axis at only one point, which is at -1.5 and 0. So I'm going to write -1.5. Once again, we have two equal real roots, which is the same as saying one real root, right? So if we graph this, we get something like this over here. So the parabola touches the x-axis at one point. Then f and g, let's calculate b squared is -4 squared minus 4 times a, which is -2 times c, which is -5. We get -24 here. That's a negative number. And let's see what happens when we graph this. Let's do f. This is f. What do you notice here? In this case, the parabola never crosses the x-axis, right? It's below the x-axis the whole time. So there are no roots here, right? There are no x-intercepts. No roots. So the nature of the roots, no real roots. And if we were to graph this, we would have something below the x-axis, okay? So that happens when this value over here, which is what we're going to be calling the discriminant later on, is negative, right? Now let's see part G. B squared is -2 squared minus 4 times a, which is 4 times c, which is 3. And once again, we get a negative number, which is -44. So the same thing should happen. Let's graph this. If we graph, we see that, there you go, the parabola now is above the x-axis and it never crosses the x-axis. So there are no x-intercepts. So if we go back, we're going to write the same thing, no roots and no real roots. And the parabola looks something like, I don't remember if it was, yes, there it is. Something like this. Okay, so it doesn't cross the x-axis. Okay, so question 2 says, the quadratic equations in part f and g have no real roots. Use your graph to explain why. Basically, that's because they do not cross. They do not cross the x-axis, right? There we go. Then, number 3. What are the 3 types of roots that a quadratic equation can have? And here we've seen one case which is 2 distinct real roots. Then we've seen this one, which is two equal real roots or one real root. And finally, the third case is no real root, okay? So let me write that here. One scenario is two distinct real roots. Another scenario would be two equal real roots. And three, the third possible scenario is no real roots. Those are all the possible cases for a quadratic function. Then number 4, what is the relationship between the nature of the roots and the equation ax squared plus bx plus c and the value of b squared minus 4ac? Okay, and what did we see here? Whenever this value was positive, we got two distinct real roots. Whenever this value was 0, we got two equal real roots. And finally, whenever these values were negative, we got no real roots, okay? So that's the relationship between b squared minus 4ac and the nature of the roots, okay? We're gonna see a summary of that in a second. Finally, for number 5, what is the relationship between the value of b squared minus 4ac and the x-intercept of the graph? Same thing. When this one is positive, we have two x-intercepts. When this is 0, we have one x-intercept. And when this is negative, we have 0 x-intercepts. That's the relationship. So, I hope the investigation was clear. If not, we're going to keep on doing this with some exercises. It says the discriminant is a part of the quadratic formula under the radical or square root sign. The symbol, and you see it's a triangle, this triangle over here, represents the discriminant, okay? So this is how we calculate the discriminant. It's b squared minus 4ac, and if you take a look at the quadratic formula, which we studied last class, the discriminant is the inner part of the radical here, okay? That's the discriminant. And the discriminant is important because it tells us how many roots our quadratic function or quadratic equation has, okay? So here it says, the discriminant can be used to determine or discriminate the number and nature of roots of the equation ax squared plus bx plus c equals 0, or the number of x-intercepts of the graph of the equation y equals ax squared plus bx plus c. And here you have the general rules that you should remember. If b squared minus 4ac is positive, that is greater than 0, the quadratic equation has two distinct real roots, which means that the graph has two x-intercepts, okay? Then, second possibility. If b squared minus 4ac is 0, then the equation has two equal real roots, or that's the same as saying one repeated root, and the graph will then have one x-intercept only, okay? And the third case is if b squared minus 4ac is negative, that is less than 0, then the equation has no real roots, and the graph would then have no x-intercepts, okay? Those are the three main rules that you should remember to find the discriminant of a quadratic equation. Then it says, reflect. Why does a quadratic equation with discriminant of 0 have two equal real roots? And that's basically because it has one x-intercept, so the roots are the same or there's only one root, okay? Why does a quadratic equation with discriminant greater than 0 have two distinct real roots? Because it crosses the x-axis twice, right? Then, why does a quadratic equation with discriminant less than 0 have no real roots? Because the quadratic function does not cross the x-axis, basically. Then, how can you use the discriminant to determine when the roots of the quadratic equation will be rational? And basically that rational means that it's not imaginary, and that's whenever the discriminant is greater or equal than 0, then the roots will be rational. Finally, why does a discriminant determine the nature of the roots? Basically, if you look at the quadratic formula, you would see that the term that causes to have more than one or two or 0 roots is basically this radical we have over here. So if this radical is a value that is different from 0, then we'll have two results, right? One for the positive and one for the negative. Now, what happens if this term is negative? Remember that there is no radical for a negative number. It's an imaginary number. That's why whenever this value is less than 0, the whole radical becomes imaginary, right? And that's why we have no real roots in that case. And finally, if this is 0, the square root of 0 is still 0. So if we do something plus 0, we would get the same thing we already had. And if we do something minus 0, we would still have the same thing we already had. That's why when this value over here is 0, the result is only 1. There's one real root or two equal real roots. Okay, so let's see 2 examples, and that'll be it for today's class. First, it says, find the value of the discriminant of the following quadratic equation and then state the number and nature of the roots of each equation. So, first thing we need to remember, first of all, is the formula for the discriminant, which is b squared minus 4ac. Okay, so for each exercise, we're going to identify a, b, in this case 5, and c, -1. So in the first case, the discriminant is b squared, 5 squared, minus 4 times a times c, and this gives us, this is 25 minus or plus 8, right? This is 33. So this is the value of the discriminant. So this would be our first answer. But then we're asked to then state the number and nature of the roots. As the discriminant is greater than 0, it is a positive number, we'll have 2 roots, right? This equation will have, let me write that here. Say the number and nature. So we will have 2 distinct real roots. Okay, and this would be the second part of the answer. Okay, so that's it for part A. Then if we go to B, we'll do the same thing. We'll identify A, which is 1 in this case, B is 10, and C, remember we need to take it to the other side, so C would be positive 25. Okay, so finally the discriminant would be, in this case, b squared, 10 squared, minus 4ac, and if we calculate this, this is 100 minus 100, right? Yes, so this is 0, okay? So if the discriminant is 0, what was the condition? That there is one real root, or 2 same real roots, right? 2 same, or 2 equal, let's call it equal, 2 equal real roots. Okay, so then state the number. Okay, and the nature, yes. So this is the value of the discriminant in this case, and this is the number and nature of the roots, 2 equal real roots. Okay, finally, we're going to see this example. It says, find the value or values of k for which the graph y equals x squared plus 9x plus k has 2 distinct real roots. Okay, so try to think about this condition over here, two distinct real roots. How does our discriminant need to be in order to have two distinct real roots? To have two distinct real roots, this is the condition, the discriminant should be greater than 0. So let me write that, discriminant greater than 0. Okay, so my equation would be 0 equals x squared plus 9x plus k. Remember, we're setting this to 0 in order to find the roots or x-intercept of the quadratic function. Okay, so if we want to have a discriminant greater than 0, we need to identify a, which would be 1, b, which is 9, and c is k, right? So the discriminant, remember from what we just saw, the discriminant equals b squared minus 4ac, and this should be greater than 0 in this case in order to have two distinct real roots. So b squared is 9 squared minus 4a is 1, c is k. This should be greater than 0, right? So if we solve this inequality, we would get, let's see, this is 81 minus 4k greater than 0. If I take the 81 to the other side, this would be negative 4k should be greater than negative 81. And here you need to pay attention. 81 divided by 4 gives us 20.25, right? But since we're dividing by a negative number, divided by negative 4, divided by negative 4, remember whenever we do this in an inequality, the inequality sign changes its direction. So this would be k is smaller than 81 over 4, which is the same as saying that k is smaller than 20.25. Okay, so what are the values of k? The values of k are any number of k which is less than 20.25. Okay, that'll be our result in order to have two distinct real roots. Okay, so that's it for today's class, juniors. I hope this was clear enough for you. If not, please let me know in the Google Classroom, and we will try to clear any doubts you may have. See you.